We want to solve the given equation containing decimals. And because 3.16d means 3.16 times d, the solution is a value of d that makes 8.21 plus 3.16 times d equal to 18.7644. In order to solve the equation for d, we need to isolate d on one side of the equation, and because the d term is on the left side, the solution will be in the form d equals some value that again makes the expression on the left equal to 18.7644. When we have an equation that contains decimals, we have a choice of leaving the decimals in the equation and solving the equation in the given form, or we can multiply both sides of the equation by a value to eliminate the decimals from the equation before solving. In this video, we will be eliminating the decimals in the equation before solving. So we want to solve the equation 8.21 plus 3.16d equals 18.7644. Notice how 18.7644 has the most decimal places. In order to make this number a whole number, or to eliminate the decimals, we would have to multiply by 10,000, which is the same as moving the decimal point to the right 4 places. And therefore, to eliminate all the decimals, we'll need to multiply both sides of the equation by 10,000. So multiply the left side by 10,000, as well as the right side. So now multiplying 10,000 times 8.21, again, is the same as moving the decimal point to the right 4 places. So if we have 8.21, move the decimal point to the right 4 places, we have 1, 2, 3, 4. We fill in the missing digits with zeros, which notice would give us 82,100. So we have 82,100 plus 10,000 times 3.16d is equal to 31,600d equals on the right 10,000 times 18.7644 is equal to 187,644. Now that we've eliminated the decimals, we can solve for d in 2 steps, which is the reason why this is often called a 2-step equation. The first step is to use addition or subtraction to isolate the variable term. We need to be careful here. It might be tempting to try to subtract 31,600 on both sides, but that does not work because 31,600 is attached to the variable d by multiplication. But we can undo or eliminate positive 82,100 by subtracting 82,100 on both sides. So next we'll subtract 82,100 on both sides of the equation. Simplifying, on the left, this subtraction undoes the positive 82,100, or this difference is equal to 0, leaving us with 31,600d on the left. On the right, we need to subtract. 4 minus 0 is 4, 4 minus 0 is 4, 6 minus 1 is 5, 7 minus 2 is 5, 8 minus 8 is 0, and we still have a 1 in the hundred thousands place value. Next, we need to solve for d by undoing this multiplication. To undo multiplying by 31,600, we will now divide both sides by 31,600. Dividing by 31,600 undoes multiplying by 31,600, or this quotient is equal to 1, and 1 times d is d. And therefore, d is equal to this quotient. Let's find this quotient on the next slide. Again, we now know that d is equal to 105,544 divided by 31,600. Let's write this in long division form. So we have 105,544 divided by 31,600. The first step is to determine how many 31,600s are in 105,544. Well, 3 times 30,000 would be 90,000. So let's see if there are 3 31,600s in 105,544. So we'll multiply. 3 times 0 is 0, 3 times 0 is 0, 3 times 6 is 18. Perform an exchange with the 1. 3 times 1 is 3, plus 1 is 4, and 3 times 3 is 9. If this difference is less than the divisor, the 3 is correct. 4 minus 0 is 4. 4 minus 0 is 4. We need to perform an exchange here. 15 minus 8 is 7. 4 minus 4 is 0. And 10 minus 9 is 1. Notice how this difference is less than the divisor. The 3 is correct. But we're looking for the quotient as a decimal, and therefore now we had our decimal point in the dividend here, move it up to the quotient, and now we can add zeros to the right of the decimal point without changing the value. So we place a 0 in the 10th place value and bring it down, and now determine how many 31,600s are in 107,440, which I think is going to be 3. We already know that 3 times 31,600 is 94,800. Again, if this difference is less than the divisor, the 3 is correct. So subtracting 0 minus 0 is 0, 4 minus 0 is 4, forming an exchange here. 14 minus 8 is 6, 6 minus 4 is 2, and 10 minus 9 is 1. The difference is less than the divisor. The 3 is correct. Add another 0 and bring that digit down. And now we need to determine how many 31,600s are in 126,400. Well, 4 times 30,000 would be 120,000, so let's try 4. 4 times 0 is 0, 4 times 0 is 0, 4 times 6 is 24. Perform an exchange with the 2. 4 times 1 is 4 plus 2 is 6, and 4 times 3 is 12. Notice how now the difference is 0, and therefore we're done. The quotient equals 3.34, and therefore the solution is d equals 3.34. So going back to our previous slide, we now know our solution, but let's check our solution by substituting 3.34 for d in the original equation to make sure it satisfies the equation. So we would have 8.21 plus 3.16 times d, which is 3.34, equals 18.7644. Let's evaluate the left side on the calculator to make sure it does equal 18.7644. And notice how it does, and therefore our solution is correct. The left side is equal to 18.7644, and so is the right, verifying our solution is correct. I hope you found this helpful.